right, so let's start today by taking a look at our first unit of the semester, which is looking at systems of equations. So a system of equations is going to be more than one equation, and they're linear. Okay, they're linear, so we're talking about two lines, and what we're going to be looking at is trying to find the solution when we have two lines. Okay, and to start with, we're going to use a process called elimination, which will allow us to eliminate a variable, substitute back in to develop the other variable's solution. Okay. Again, we're going to solve systems by using a process called elimination today. So let's start with what a system of equation is. So systems of equation is a group of two or more linear equations. Okay, two or more, and we're going to be specifically looking at two. Okay, specifically looking at two. So I'm going to have you think about just for a second. If I have line 1 and I have line 2, they are going to probably intersect at some point. So what we're actually looking at when we're solving a system is we're looking for where the two lines touch. We're looking for the intersection of the line, which means we're looking for an x and a y. Okay, an x and a y. We have to have two solutions because there's two linear equations. Okay, and our first method that we talked about is called elimination. Okay, first method to solve is called elimination. The second method we're going to be looking at is graphing. That will come up a little bit later, and we're going to be looking for the intersection point. Okay, we're going to be looking for the intersection point. So as we start to talk about elimination method, we need to talk about what does eliminate mean. Well, eliminate means get rid of. Okay, to get rid of something. So in math, I want you to think about how do we normally get rid of something? Anybody have any ideas? Well, hopefully you're thinking, oh, wait a minute. I think I remember, so like when we're solving equations, like x plus 5 equals 10, if I subtract 5 on both sides, didn't I cross this out? Well, crossing that out is technically eliminating because I'm eliminating because it made a 0. Okay, and what we notice with a positive 5 and a negative 5 is those are opposite. Okay, those are opposites. And those are called additive inverses. Okay, they're going to add to make 0. And that is what we're going to be looking for, is those additive inverses. So if I give you positive 8, the additive inverse would be negative 8. If I gave you a positive 3, I'd be looking for a negative 3. And when we're talking about variables, it's the same thing. So a negative 4y, positive 4y. Notice the variables are the same, the coefficients are the same, and the only thing that is different is the sign. A positive 5x would be a negative 5x. So that's what I'm looking for. I'm looking for these additive inverses, okay? Okay, so let's take a look at this first equation, okay? And if you've got your colored pencil, get your colored pencil out because we're going to be using it, or even a highlighter would work, or a pen. Write this problem down, and let's go through the process of solving a system with elimination. So the first thing we're going to do is find the additive inverse. Okay, find the additive inverse. So I'm going to take a look at this. I have a 2x and I have a 1x. Well, those are not additive inverses. One's a 2, one is a 1. So that's not what I'm looking for. Let's look at the y. This is a positive 1y and a negative 1y. That is what I'm looking for. I have a positive 1 and a negative 1. So I am going to box the additive inverses. I'm going to cross them out, draw a line, and I'm going to put a plus sign here. Okay, I'm going to put a plus sign. And then what I'm going to do is add down. Okay, I'm going to add down. Notice that my y's are gone because they're the opposites. 2 plus 1, that's a 3x. 0 plus 3 is 3. And then I just have to finish this problem, which is super easy because I know that this is multiply. My last step is going to be divide. So 3 divided by 3, x is 1. Okay, x is 1. So I know that since this is x and my ordered pair is xy, the 1 is going to go in the first spot. So I have the first part to my answer. All right, now, how we get the second one is we're going to use substitution. Okay, we're going to go back to one of our equations, and I'm going to go ahead and pick the first one. So 2x plus y equals 0. And I can remember that there's a 1 there. And since this is an x, it is going to substitute in for the x. So 2 parentheses, I'm going to put in my 1, and I'm going to finish solving the equation. 2 times 1 is 2. 2 plus 1y equals 0. Okay, well, let's think about what's happening here. So the y is here. The closest number to the y is the 1, so that's a multiplier. So I'm going to multiply by 1. The opposite is divide by 1. Well, this 2 is a positive 2 because there's nothing in front of it. So the opposite would be minus 2. So the first thing I'm going to do to start solving is subtract my 2. And this is gone. My 1y drops. 0 plus negative 2 is negative 2. Now, I can divide by 1, but it's not going to change anything. My answer is still negative 2. Okay, my answer is still negative 2. So my solution, which is an ordered pair, is 1, negative 2. Okay, let's look at the next one. Do I have opposites? Do I have the additive inverses? Is it the y's or is it the x's? Hopefully you saw that it was the x's. So I'm going to draw the box, cross them out, draw a line, and make a plus sign. Okay, now I have to remember, this is a 1 and this is a 1. 1 plus 1 gives me 2y. 2 plus 4 gives me 6. Now I'm going to divide. Divide by 2, both sides. This one's gone. 6 divided by 2 is 3. 6 divided by 2 is 3. Okay, now, this time, instead of picking the top equation, I think I'm going to pick the bottom equation. And the reason why is because it doesn't have any negatives. And if I can eliminate dealing with negatives, that would be a good thing. Now, I have to remember that these are 1s, okay? And I'm going to throw my 3 in for the y. Well, 1 times 3 is 3. So what's going to have to move first, the 1 or the 3? Yep, it's the 3. So minus 3 on both sides. I have 1x equals 1. And I don't have to go any farther than that because I know dividing by 1 is not going to change anything. So my y is 3. That goes in the second spot. My x is 1. That goes in the first spot. Let's do a few more. Okay, why don't you hit pause and go ahead and see if you can start these problems, and I will catch up with you. Okay, so start these problems. See if you can make some progress. Remember to find your additive inverses first. Box them out, cross them out, draw a line, add, and then substitute back in. Okay, let's see how you did. So if I take a look at this first one, I see that I have y's that are opposites. So I am going to bar the box, cross them out, and add. 2 plus 2 is 4. 4 plus 0 is 4. Dividing by 4, I see x is 1. So that's going to go in my first spot. Okay, I think I'm going to grab the first one again because, again, it has no negatives. And since I have an x value, I know it's going to go next to the 2. So I'm going to put my parenthesis in there so that I don't lose negatives. I'm going to put my 1 here, and I'm going to evaluate. 2 times 1 is 2. 2 plus y equals 4. I'm going to subtract 2 to get y by itself, and I come up with y equals 2. So my solution is 1, 2. It's 1, 2. Okay, let's keep going. If you haven't done the next one, hit pause, see if you can figure it out, and then check yourself by continuing with the video. All right, here are my opposites. 3 plus 3 is 6. 4 and 2 is 6. I'm going to divide by 6, and I come up with x equals 1. Okay, again, looking at my equations, I'm going to find the one that has the least negatives, and I see the bottom one has less negatives. So x plus y, x plus y equals 2. My 1 is going to go in for the x. So 3 times 1 plus y equals 2. That's going to give me 3. And of course, the 3 has to move, so I'm going to subtract. So y equals 2 plus negative 3, that's a negative 1. So I've got my solution. I've got x is 1, y is negative 1. All right, let's see what happens on this last one. Here are my additive inverses. This time it's the x's, not the y's. Let's add. 6 and 6 is 12. 21 and 15 brings me to 36. Dividing by 12, I see y is 3. Okay, again, pick the one that has the least negatives. I'm going to drop my 3 in for the y because it is a y. Using parentheses, 3x plus 18 equals 21. Subtract my 18. That's gone. 3x equals 3. Divide by 3. X is 1. So my 1 is going to go first. My 3 is going to go second. Okay, we got one more. And then we'll cut you loose to get some homework done and try some of these problems. Okay, so these both are very interesting because I don't see that I have additive inverses. I see that I have a negative 1 and a negative 1. They're the same. So these are the same, not additive inverses. Does anybody have an idea how I can make one of these a positive 1x? What could I multiply this top line by to make a negative 1 a positive 1? You're right. I could multiply by a negative 1. So let's go ahead and do that. I'm going to write this underneath here, this other problem. So negative 1 times 2, that's a negative 2x. Negative 1 times negative 1, that's a positive 1y. And a negative 1 times 17 is a negative 17. So now this part's gone. Now do I have additive inverses? Yeah, I do. I see them right here with the y's. So now I can do the same process I was doing. So 1 plus negative 2, that's a negative 1. My y's are gone. 10 plus negative 17 is a negative 7. I'm dividing by a negative 1. Negative negative is a positive, so that's going to give me 7. Okay, so I am going to use the second equation, the x minus y equals 10, as what I'm going to substitute into, instead of going back to the top one, because I crossed that one out. I'm going to throw my x in here where this, or my 7 in where the x is. So I have 7 minus y equals 10. And I have to remember that that's a negative 1y. So I want you to think steps for a second here. So this is multiply negative 1, divide negative 1, plus 7 minus 7. So the first thing I have to do is subtract that 7. And I have negative 1y, 10 plus negative 7, or 10 minus 7 is 3. And now I have to divide by that negative 1. So y equals a negative 3. So I have my two solutions, 7 comma negative 3. Okay, let's look at one more like that. See if we can figure out how to create that additive inverse. How to create that additive inverse. So notice how I have a 7 and a 9. Those aren't even the same numbers, so that's not going to help me. But I see that I have a negative 1 here and a negative 1 here. So let's go ahead and multiply again by that negative 1 on top. So negative times negative, that's a positive. Again, negative times negative, that's a positive. And this is going to give me a negative 9. Okay, so now my additive inverses are the x's. 9 plus 7 is 16, and 23 and 9 is going to give me a negative 32. Divide by 16, y equals negative 2. Okay, so I have the first part to my answer. Now, there isn't really a good one up here that doesn't have a lot of negatives, so I'm going to go ahead and just pick the second one. And I'm just going to have to remember that there's a negative 1 here when I'm solving. And I'm going to put my negative 2 in here with the 9. So negative 1x plus 9, drop in my negative 2. And I'm going to evaluate. 9 times negative 2 is negative 18. And I really don't need to have this plus minus thing going on here. So I'm going to change this to negative 1x minus 18 equals negative 23. Okay. I'm going to add my 18 because that would be the additive inverse. This is gone. Negative 1x equals negative 5. Divide by negative 1, x equals positive 5. So my solution is 5 comma negative 2. All right, go ahead and get started on your homework today. I don't think any of them should turn out to decimals, but definitely reach out to us if you are struggling. Remember to look for those additive inverses and substitute back in to solve for the other variable. Have a good day.